Okay, the problem is number of substring containing all three characters. That means we are given a string consisting only ABC. Okay, return the number of substring containing at least one of the occurrence of this character ABC. So what is meaning that one string is given to us containing only three character ABC. So let's say A, B, C. This is our string. Okay, let's say this is our string. So what are the substring that containing our ABC? So there are two substring containing all three character. That means ABC. So if I take this string, this is the ABC, and if I take the entire string, that is ABC. AABC. These two substrings are there. So these are the cases, right? So this is the example. Let me give another example. Before that, let's see what are the constant. Constant is it could be 3, it could be anything. So 500 to the power 4, and only constant it will that A is only content A, B, and C, nothing else. So let's say all the cases. Like let's say take an example, one proper example. Let's say fast example given in the LeetCode ABC, ABC. So if I have to take like find out the substrings, then in containing all like at least one occurrence of ABC. It could be more than one, but at least one occurrence of each. So brute force, if you think about the brute force approach, then we have to generate all the substring. That means A, B, ABC. Then this is how we can create all the substrings, and all the substrings in each substring we can find the count of ABC. If the count of ABC is more than one, then it's fine. But this is a brute force approach, and it will not satisfy because see, time complexity is big of n square. Generating all the substring will iterate at each time, starting from here, then generate entire substring, then starting from here, then generate entire substring, then starting from here, then all the substring from this position. This is how we generate the substring in a brute force approach. So then it will take n squared time, so it will take 10 to the power 8 times. So obviously it will take gives us TLE. So let's see some before that. Let's see what are the substring possible. Okay, what are the substring possible here? So generally, this ABC is a one substring of this entire string, right? So ABC could be one answer. So one substring is ABC. Okay. So what are the other case? If ABC is a substring, so containing this ABC, all other substrings also satisfied. See, because see, this ABC is a valid string because it contains one single ABC. Then this one is also valid, this one is also valid, and this one is also valid. So ABC is valid, then the next one is also valid. Fine. So that is one thing I am noticing. If one part of the string is part of a substring, is a valid substring, then all the remaining character can be added, and it will be another my answer. Okay, another valid answer. That means what mean to say. So ABC is a substring. So if ABC is something, then A, B, C, A is a substring. Then A, B, C, A, B is also a part of valid substring. Then ABC entire substring is a valid substring. Why it has happened again? I am saying because this ABC was part of my substring. So whenever this is a part of substring, then this entire group would be my part of my answer. I can append one item into each. Okay, fine. So after see, let's say another case. If I have taken this entire choosing for the first, I'm starting from the first character and got the ABC, and then I'm looking this. Let's remove this one. Okay, so this part is done. So let's see about this part. In this part, I can simply see this BC is a substring. So if BC is a substring, then all the cases will be the valid substring. That means if I write it down, that this BC is a substring. So BCA is a substring, valid substring. Then BCAB also a valid substring. Then BCAB and C, this is also a valid substring because each valid substring means each substring should have at least one occurrence of ABC. Okay, fine. So then this part is also done. Considering this part is also done, let's discard this D and check only this part. What we could see. So you can see CAB is a part. CAB is also a valid substring because again it's a containing at least one occurrence of each. Okay, so C, A, B have a substring, so I can do what? Then C, A, B, C is also a valid substring. Fine. Okay, fine. So this part is also I have taken. So let's discard this C as well. So if I discard C, we can see again ABC, another ABC. So another ABC I can get another ABC. So you can say like ABC is a part here also, here is also ABC. So should I take a single one? No. They didn't ask me for unique substring. They have asked me all possible substrings. So it may appear twice. See here. So this ABC is coming from this part, this ABC coming from this part. Two ABCs is there in my substring. So it is valid. So whatever valid substring is there, you have to take it. So if you notice one thing if you notice what we are actually doing, we are fixing some of the valid substring. We are fixing some valid substring. If I get a valid substring, then I can take other substrings as well. So this is it is kind of a think of it as a kind of a window you are creating. One window you are creating. So if one window is satisfied, one like the window like all the valid strings are present, then I can take remaining character and create that count that valid substring. So let's take another example. Let's take A C B A. This is the case. So what is our fast occurrence of my valid substring? So fast occurrence of valid substring is starting from here. Fast occurrence nothing but this part. If you notice, this part is a fast occurrence is a valid substring. Why? So why not only this A? Why not only A? Because if I only consider this A, there is no C and B present. So C and B must appear at least once. So that's why my fast occurrence where A, B, and C all are present. This is my fast occurrence. So this is my fast occurrence. If this is my fast occurrence, let me mark it down. So if this is my fast occurrence, then what is the valid string? A C B is my valid string. So if that is the valid string, as I told you, if this part is a valid, then other two characters I can add. So other two characters like also contribute to substance. So when we find a valid window, we can say it's a window, valid window where when we find a valid window where my substring is valid, then the remaining numbers. So remaining numbers are also valid. So how could I get that? So let's see our index. It is nothing but 0, 1, 2, 3, 4, 5, 6. So window means I need how much it is. So last index in my window is 4. So how many characters it is contributing actually? It is contributing itself and remaining two characters. How could I get remaining two characters? Simply n minus 1, that is 6. 6 minus 4, that extra 2 it is contributing, plus 1. Plus 1 means why? Itself. So 2 characters plus itself. So if you notice, it's actually pattern of what? So pattern of 6 plus 1 is nothing but 7. So you can divide it 7 minus 4. And this, what is this 7? This 7 is nothing but my length. My length of this word. Length of given string is length of is. Okay. So simply I can do what? I can do whatever my length, actual length of that, and what is my valid window. I can do what? So whatever my length is, the length is 7. What is the last index of my valid window? I can simply subtract, and from the subtraction I can know that this window for this character, for the characters present in the window, they can contribute 3 kind of substrings. What are the 3? Let me example again. 1 A C B. This is one substring. These are the characters present in the window. So this is contributing itself, and it can contribute other 2 substrings. These are the other 2 substrings. So this can contribute 3 substrings. Okay. So now we have to move the window. So how could we move the window? So can we move our window like this to this? Can we move it? You can think of it, but think if we move that window from this to this, we are missing some of the cases. What are some of the cases? See, if this one also contribute one substring. So let's see. how many substrings we get. So if I move this window, let's see what are the cases we are missing. So if we move this way, so what are the substrings? Again we get formula. Formula is 7 minus 5, that is 2. So 5. So still now 5. So again I want to move the window. So if you just simply move the window, so what is the problem? Let me show you the problem. If I move the window, what is the substring? Formula 7. Current last index is 6. Last index in the window is 6. So it will be 1. So how many it is contributing? 3 plus 2 plus 1. That is nothing but 6. If I move that window. But think this way. Think this way. So earlier we are getting this one. Earlier initially my window is this one, right? If window is this one, that time it is contributing how many times? 7 minus last index in the window is 4, so it is 3 times. So instead of moving window as a whole, can I reduce the window? And check? See, if I reduce the window, number of A is reduced, but even though number of A is reduced, still number of A is more than 1. I need at least 1 A, right? So at least 1 A can contribute. Now this window, so this smaller window can also contribute. First, then what I were doing, actually first I am checking entire window, fast valid window. I am searching for the fast valid window. The fast valid window we are getting. After getting the fast valid window, can we check, like, if we remove some of the part, like earlier part, the previous, so see, if my fast valid window is this one, this entire thing is my fast valid window, that means what? Something is missing in the outside, previously, some character is missing in previously, but added in the last, correct? So that means, so that means what? So if it is an ideal window, then the window should be length 3. If in the ideal window in the sense, each character appearing at least one time. So it is ideal window. ABC, BCS, EAB, entire combination, 6 combination like is there. So this is the valid window if it is ideal window, but it is not the ideal window. It is more than my length 3. More than of length 3 means what? So some of the character that has appearing multiple times, and it is appearing in the beginning. How can I say in the beginning? Because so if it is not in the beginning, then my window should have ended before that, in this place or in this place. It is ending at the end. At the fast time it is closed at this place. Fast time it is taking up to this place, right? Fast time it is taking up to this place. That means what? That means my all characters are appearing once at this moment of time. That means what? I can reduce some of the beginning character. So there are possibilities that some of the character is appearing multiple times before 1 or 2 times before. So I can remove the fast characters. Not letter character. I will check the letter character later. So I will check, remove the fast character, second character later, and check whether my window is still valid or not. If it is valid, then the window itself again contribute, right? So that's why I'm moving the window from reducing the window from left side. So this is the typical sliding window cases. Like the sliding window, we increase the window right side and decrease the left side. So while we are decreasing, we are checking that after reducing, the window becomes valid or not. If it is not valid, we will do something else until or unless it is valid. If it is valid, then it will also contribute to my answer, right? So that's the reason we will not only just reduce the window from earlier it was this, from this to this, we will reduce it. So you can see, number of A, number of B, and number of C's are kind of good. Like it's satisfying the condition, like each 3 characters at least 1 it is appearing. So it is fine. So again I will use the formula like 7 to the last character 4, that is 3. So fine. Again it is a valid one. So unless we get the invalid, we will change the window. So again I will change the window. I will reduce the window. Again it's a valid. So again I will do 7 minus 4. 7 minus 4 equals to 3. Again it is a valid case. Now let's say another case. Now again reduce the window. So again after it is reducing, now say it's invalid. So whenever I got it invalid, that time I have to increase the window again. I have to increase the window again to the right side. I have to increase the window. So increment always happen from the right side. decrement reducing always happen from the left side. So I will reduce the window. Fine. Okay. So after this, again, what is the formula will be? So how this part will contribute how many times? This part will contribute. See how many times it will contribute. This one contribute for itself and also this character. So nothing but 7 minus 5. Two times it will contribute itself and another one character. Two times it will contribute. So we can simply write 7 minus 5 equals to 2. Okay, fine. Again, I will try. If it is a valid window, I will try to reducing the valid window. So I will try to reduce. So after reducing, am I getting the correct one? Because see, I already have taken this part. I have already taken these all characters. Starting from this index, I have taken I have taken all the possible substring using this formula. So for using this formula, I get all the possible substring. So what is happening? So right now, so that means I have taken this part. So I can discard this C and check like in this part is create a valid substring or not. So I will do what, as I told you, when I get a valid window, I reduce the valid window size. I reduce the window size and so like it is not a valid one. If it is not a valid one, I will increase it. So after increase also, like it is not again valid window because C is missing in this place. So after that I can't increase. So whenever I am my right pointer is out of index, I will stop and I will sum it up. All the cases I get. How many times? 3 times 3, 9 plus 2, 11 times is there. So if you find a substance, we'll get 11 times. Let me show you. Is it present 11 times or not? Okay. So let me show you first. So you can see this, as I told you, this one is a valid one. AACBA. First valid case. So triple A C B, it contribute itself and two A's. Okay. So let me write it down. So it will first one will be triple A C B. It is a single one. Now it will contribute triple A C B single A. That will contribute triple A C B A A. So all three are done. Now I can take this. This is also a valid string, right? This is also a valid string. So if this is a valid string, then what is the cases? The cases are 3, okay, 4, 3. So if this is a valid case, so it will be AACB is also a valid case. So it will contribute again 2 times apart from itself. So it will contribute this many times A B C B A A. Now that many times it has contributed. Fine. After that, this part is also valid, right? So it will contribute again 3 times, including itself. So it will contribute 3 times. So that's why it will contribute 4, 5, 6, 7. So A C B A C B, 8 A C B A, and 9 A C B A A. Okay. So after that, what they will contribute? Then see, the CBA is also a valid one. CBA also a valid one. So it will contribute twice. So 9, 10. So CBA also contribute and it will contribute another one. CBA. You can try any other combination. So these are the valid substrings present in this case. So this is the simple sliding window protocol. So whenever I'll start my window at 0, 0, I'll include the first character and check whether all the frequency is correct or not. So let me give a proper example and given write a proper dry run. Let me show the dry run. Just a minute. Let me take one example. The test case I should have. Okay, the test case. Okay, let me create one test case. So let me create one test case. Let's say A C B A B A C A B A A. So let's say this is the case. So right now, see here. So it is a too long. It is. You cannot generate manually. Okay. So how could I do this? Let me give the index number 5, 6, 7, 8, 9, 10, 11, 12, 13. 14 length index is there. Okay, so how many index we can create? So first, as I told you, everything will be here. So everything will be stored here in this place. Left and right is initialized as a 0. Okay, let me don't use the pointer. So obviously we can't use window. We have to use our left pointer and right pointer. Okay, and I need three variables to store the count. Let's say frequency map. We can use map data structure, or you can use list. Any list means array. Anything is fine. Array vector you can use. I am just counting the occurrence frequency of A, B, C. Initially it was 0. So my loop start. The loop start is where. So my R is currently at the 0th index. So I will increase whatever the current values are. I will increment that R. So R is right now pointing to A. So A is nothing incremented by 1. See here. So in this window, this is my window. In this window, single A is present. So that's why when the loop start, I will what is the R is there. I will take that R. After that, I will check whether everything is fine or not. Everything is more than 1 or not. If it is more than 1, then it is a valid window, then I can calculate what are the substrings they can generate. Or this is not a valid window. So whenever it is not a valid window, R will be move forward. Now R will point here. It is also again A. So A becomes 2. Fine. So again it will forward and it will come this place. A it becomes 3. So again it will forward and R comes in this place. It becomes 3. Okay. So in that place, in the third index, what is the count? Count is C. So is it a valid window? No. B is still missing. B is still 0. When everything is non-zero, then only I can do the uh, calculation. Like that substring I can take, and apart from the substring, all the remaining character that will be what are the substring can be created by all the remaining character that can be also be created. Okay, so I can take that. So okay, count of C I actually mistakenly written as C here. It should be count of C becomes 1. Count of C become 1. So count of B is 0. Count of C is 0. So again R will be here. So here it becomes count of B becomes 1. So here see at this moment of time, whenever my R reaches to B and count is 1, at this moment of time, all like at least one character each present in my selected window. Okay, so that means what this window when this is L and this is R in this position, this is the fast valid case. All three characters are present. Now I can take all these character and also take these characters. So this is nothing but this many characters and this one plus one. So I can calculate the formula that length. What is length here? Length is 14. 14 minus 14 minus what? 14 minus 4. 14 minus 4, that means 10. So it will be count as a 10. So count is nothing but my initial is 0. So that count is storing my number of substrings. So it will, can number of substrings that is fulfilling the condition. So I will add the 10. So whenever this is the case, whenever my R is actually a R not R, my current window having all the characters, then I have to check what will happen if I reduce the L. If I reduce the L, what will happen? So L will be reduced. L will be come this place. So while coming, L was A, so it will reduce A and come to this place. So here also the condition is satisfied because this is 2, this is 1, this is 1. Condition is satisfied. So that means I can rewrite again. So it's a 14. What is the current R? R position is 4. It is again 10. See, because see, my right now, this is my L. This is my L. So earlier, this thing, from this thing to this thing, right? From this to this. Earlier, this to this can contribute itself plus all the 9 things present in this place. All the 9 things. So right now, this also is a valid string. This also is a valid string, and including this again, it can I can take these 9 characters, including one by one, and this also becomes a valid substring. See, this is a valid substring, isn't it? This is a valid substring, and so as it is a valid substring, I can take 9 character one time each, append one by one, and generate all the substrings, right? So that's why it is also 10. It will create 9 itself. Other 9 plus itself plus 1, so 9, 10. So this is the formula, like length of the string minus the current position of the R. So this is how we can check. Okay, so 10 will be added. Fine. So again left will be moved. So before left will move, it will reduce the current L pointer pointing to this pointing to A. It will reduce the frequency of A and it comes to this place. So this is also again a valid substring because see, all are 1 1 1. So all are 1, so it is a valid substring. It will do 14 minus 4. 14 minus 4 again 10. So it is 10. Okay. Again 10. After that a again reduce. So before reducing it becomes 0 and it becomes l is here. So whenever l comes at this place, see, whenever l comes at this place, that time I cannot reduce furthermore. Why I can't reduce? See, because if I reduce furthermore, so it is already 0. A is 0. If anything is 0, I have to stop, and that time I have to increment my r. So I cannot reduce l, so I have to increment my r. So r comes in at this point 1. So it will be incremental. So L again becomes 1. It again becomes like R pointing to the A. Sorry, R pointing to the A. A becomes again frequency becomes 1. So again, see, everything is containing 333. So if everything is containing 333, not 333, like everything containing at least once, that time it can contribute again. So that time, in that case, this string from this L to this one is a valid string. This is a valid string, and it can contribute itself and all the rest of the 8 characters. So 14 minus 5, that is nothing but my 9. So it can contribute 9 times. Fine. Okay. So I will try to reduce. L. So L is kind of pointing to C. So it will be reduced. L pointer to the this place B. So it will be pointing to C right now. It becomes 0. Now see here in this point, like what is the count of A, B, and C? Frequency of A, B, and C. C becomes 0. It is not a valid window. So this is not a valid window. This window is not a valid because it is containing only A and B. So it should contain at least A, B, and C at least once. So I have to increment the R. So I have to increment the R. So it will come in this place. Now B1, it will point, R is pointing to the B. B is count will be increment, it will becomes 2. So it is a valid window? No, because C is still 0. So R will be here, come here. It will count A. So is it a valid case? No, it's not a valid case because C is still 0. So R will count here, come here. So it will increment A, it becomes 3, A becomes 3. It is a valid case? No. Now R will come in this place, C. So at this moment C becomes 1. So this is a valid case, C becomes 1. So from that A, L to this C, this is a valid window because from this L to this C, this is a valid. So what is the count will be? Count will be 14 minus 9. Nothing but 5. So this is a 5 time will contribute. Now whenever the string is valid, now I have to reduce. I have to reduce my L window. I have to reduce the window. So right now L will come in this place. A will come this place. It will reduce what? It will reduce B. B becomes 1. It will come here. So what is the, is it a valid case? Yes, all are appearing at least one. It is a valid one. So I have to again add 14 minus 9 equals to 5. So I have to add 2 5s here. 5s and plus 5 I can add. So again L will be reduced. L will come in this place. So A, it is before reducing, before going to there, it will reduce the current frequency. Current frequency is A. The A will reduce by 2 and L will come this place. So it is also a valid one. Everything is 1 1 1. It's a valid one. Okay. So if it is a valid one, then what will happen? I'll have to again do 14 minus 9, again 5. So 5 is there. Fine. So again it will reduce current L, whatever the L is pointing to, that character frequency will be reduced and it will becomes, it is B, so this becomes 0 and L comes this place. See this place. Now this window, in this window, what is the current window is there? This is not a valid because B is missing. B becomes 0. Frequency of B becomes 0. So this is not a valid pointer, right? So what will happen right now? Again I have to do increment the R. So I have to change the R. So let's change the R. R comes in this position. It's a valid window. No, because A will be incremented and it becomes 3. B is still missing. So R will be again come here in this place. B becomes 1. So is it a valid window? Yes, it is a valid window. So what is the how many string it can contribute? So what is the valid window actually? This is the valid window. Starting from this A to this B, this is the valid window. So what is it can contribute? So let's see what it can contribute. It can contribute to 14 minus current is the 11. So 3 times it can contribute. So whenever the window is valid, I will reduce the L. So the L will be coming in this place. A will come this place. So first reduce the number of A, frequency number of A, so it becomes 2, and then L comes next place. So whenever next comes, is it a valid window? Again, it's a valid window because everything is appearing twice. It's a valid window. What will happen? What will happen? So 14 minus 11, again 3. So plus 3 plus 3. Okay. So this is fine. So again I have to reduce A. So A will come 1. So let me reduce. So let me come, it is 1. So this one, A will be reduced and it will come here. So this is valid window. Yes, it is also valid window because see, in this window everything is still a valid one. It is a valid one. So again it will be added in my case. So it will be 3. Another 3 will be added. Now see here. Now again it will be decremented by its choice because it's valid. Until whenever it's valid, I'll reduce this. So it becomes 0 because L is currently pointing to C. It is valid, so it will come into this place. So see, in right now, this one becomes invalid because C becomes 0. It is invalid. So it will not contribute. What happens? Now? I have to increase the R will now point to new place. So this is new A. So A will be incremented. A becomes 2. Okay. Is it valid? No. C is still 0. So R will becomes incremented. It will point to A. Is it valid? No, because it is incrementing frequency of A. So R right now incremented and goes out of index. So that means what? So I don't get any valid index. So whenever I don't get any valid index, that means no pointing to move well. So whenever I got window is valid, that time I only reduce a window. If my current window is not itself valid, so no point of reducing the window. So entire window is not valid. So these are the all number of substrings present in this string. Okay, this 13, 14 character. Let's see how many times it is present. Let's count it. It is 30 times. 30 times is there. This is 50 times. 15 is there. 50 times. This is 9 times. So 30 plus 9 plus 9, 18 plus 30 plus 15, 45. 45 is 65, 65, 63. See, 63 substrings are present. 63 substrings are present. So within 13 length of 14, 14 length of substring, 63 substrings present, that is satisfy my condition. But that matters. That depends on, this is how we can do. We cannot generate each and every time. Each and every substring we can check it. Okay. So let's see right now. Let's see what is the algorithm of this merge. So in the algorithm, we can write this way. Let's say find function. Our function is number of substrings, right? Number of substring. What is given to us? Given to us one string S is given to us. Nothing else. Okay. So let's, as usual, find let's say our length of the S. So S dot length. Okay. So find that, and we need some map, like we have to store the frequency, right? So for now I'm using the map, so storing the frequency. So frequency of map, frequency, it is nothing but one map data structure, and it will store like one character as a key, character nothing but A, and it will store integer as a frequency. So it is the map data structure I have created. Okay, so I have to populate this map. So frequency of A is nothing but 0. Then B frequency of B is also 0, and frequency of C is also 0. Frequency of C is also 0. Everything is 0. And I also need some variables like initializing variables, in the sense like left, right, and our count, right? So all need to be 0. The left is equals to right is equals to, and count I need to store the count of the total count of the our valid substring, or as 0. So okay, so write our loop is starting from while. So my, in the string, let me write some string. So A B C A B. Let's say this is a string. So R should start from in this place. So in this place R should start, and it will start from here to here, right? So that's why while I am writing the while loop. While r is less than n, while is r is less than n, so that time still it will loop. So whenever r is less than n, so I have to start the my window. So first, whenever I while move, so right now it is zeroed index, so I have to consider the zeroed index. So I simply write that frequency of current s of r, whatever the currently r is pointing to, that I will increase by 1. I'll increase by 1. So okay, so if I have to say if it is a valid index, so it is valid, so if it is a valid window, how can I check? Obviously this is not a valid because I am only considering one character, but my loop should work in a generic way. So if it's a valid case, so I will write another loop while my this all frequencies, I will take this example, all this one, copy, paste, entire this thing is valid. Okay, so entire this thing is valid in the sense when entire this is greater than or equals to greater than 0, that means all are present at least once at one time. So all are if a valid one, so all are, let's say write it, if is greater than 0, if it is greater than 0 and if my this one is greater than 0 and this is also greater than 0, if these are the cases, if these are the cases, all are greater than 0, all three, if all three are greater than 0, then it's a valid window. So whenever what we do in the valid window, whatever we get valid window, we increment the count in our total. So it will be count will be incremented. So count plus equals to this my length of the my string minus current r position, that will include. After that, whenever the window is valid, we reduce the window. So before reduce the window, let's reduce the frequency wherever my L is pointing to. So frequency, so S minus L, wherever L is pointing to, I will reduce the frequency. After that, I have to increment the L so that it will, like L is also, let's say at some point of time, um, let's say this is my case. So some point of time L is here, L is here in this point and R is this point. So this is a valid case. So that time L will be moved forward so that window can be reduced, right? Can be reduced. So I'll reduce the window. So after that, reducing the window is done. When this is the case, when the window stays valid, the same thing I have to do, because this is a valid window. Let's say this is another valid window. So again I will count it. Again L should be reduced. So until when it will be continued, should be continued until my window becomes valid, it should continue. After that, whenever the window becomes invalid, this loop will break, and that time I have to increment my r by increment by r. So that time r should come in this place. I should increment the r. Simple. So that's all. Then I have to close this one and return at the end, return the count. Return count. Return count. So this is all it is needed. So what is the time complexity of this problem? See, clearly 2 pointer you are using. 1 pointer r is moved this side to this side. Okay, r is starting from here to at the end of the loop. So for seriously, for sure it will take big of n. And but say big of L is also there are 2 while loops are there. Okay, 2 while loops are there. It's 2, but it is not for single r, L is not traversed to this place or this place. For single r, r is here, L can be some place, it will come back this place. And after the whenever, look at me, but let me say L, what actually I mean to say. Alright. Okay. So what I mean to say, let's say some point r is here. Let's say r is here and L is here. Let's say some hypothetical, some cases, r is here and L is this place. L is this place. So L can move some place, after some place L can move in this place, okay. But L will move for this A. So whenever R comes this place, if L needs to be moved, AL will start from this position. AL will not reinitialize from this place, and it will not move from this place to this place. Whatever the current AL is there, then AL is moved from this place to some other places, right? So it is not for it is not a for each index. It is not iterating for entire case. Okay. So if you think that, so R is typically moving from this place, zeroth index to last index. L also moving from zeroth index to the sum of the index, and only once, not twice as well. Only once. Both are moving only once. So it is big of n. It could be n plus n to n, but in time complexity we write entire thing. We write big of n. Okay. So time complexity, it becomes big of n. 2n you can think, but big of n is also fine. Space complexity, are you taking any extra space? Yes, but only three space for count the frequency. Okay, so no extra space. So this that 3 is another constant one. So I can think big of 1. This is the thing we can think of it. Okay, so this is the one of the approach. So the thing is here, what happens actually, that L are also moving from right to left, L also moving right to left. So at most it will take big of 2.5 time. So can we optimize in a single goal? Can we do this single iteration? So for that we can do that. Okay, how could we do that? Let's see an example. Let's take this example. Copy. See this example first. If this is my string, let's find it out, that current way of find, like current position of the A, B, and C. Okay, current position. Okay. So I'll iterate for one character at a time. So A, B, and C. This is our three variables to store my current position of ABC. Initially, everything is nothing. So it is the what it will store. It will be storing the index of latest A and B and C. Okay. It will get the latest in the sense like whatever appeared the last appeared ABC's position. Okay, let's see. Okay, what happens in this place, like A is there, so initially I initialized every value with -1. Okay, so -1. So right now my pointer, I will say iterate for each character and update this last operands. So right now my pointer is this one 0, so it will the A, so it will appear again. It will, like, whenever I'll get nothing is -1, then I will do something. What I will do, I will say. But let's see. Like right now everything is -1. It is -1. Then we will don't do anything. If it is all our valid position, then it's fine. Okay. Now pointer comes this place 1, so this 0 becomes 1. Fine. Then its pointer comes this place. This 1 becomes 2. Fine. So this pointer comes to C. So C is kind of 3. Okay. So right now again pointer comes to B. This becomes 4. So right now see the case. So right now my current pointer is B, right? So it is index number 4. Right now the index positions are 2, 4, and 3. 2, 4, and 3. Okay. So whatever this 2, 4, and 3 is there. So what is the minimum among this? So among this, minimum is this one. And what is the maximum? That is this one. Maximum is not required, but okay. So this 2, 3, and 4, if I consider this is a valid one, right? So that's why I'm kind of storing the pointer. So 2, 4, and 3. We are storing the latest recently visited ABC. Okay, so that's why we are storing 2, 4, and 3. So 2, 3, and 4. So 2, 4, and 3. This is the latest one, right? So this is the one. This is the last valid window. You can say last valid places where it has appeared. So if it is appeared this time, so that means that previously I didn't count the previous, right? So previously it will also must have participated. It should have participated. I didn't count this one. So these two, how many times it can result? Earlier we are considering the left side, right? Now we have to consider the right side. How many times it will can do right side? So whatever the minimum is there, So 2, 4, 3, whatever the minimum is there. Okay, minimum is 2. So that means current minimum index is 2. Before that, how many index it has participated? Like 2 minus 1. So sorry 0 to 2, 0 to 2. So it should have we can create a valid window. So what actually mean to say this right now, the latest index in latest ABC positions are last appeared ABC position are 2, 4 and 3. This 2, 4 and 3. So in this window, this is a valid window. So if it is a valid window, so what is the minimum one? Minimum one. So that means it can create one window like this, and like this. All three windows can be created. So how could I find out the window created? I take the minimum one and simply do the plus one. Simply do the plus one. So it can contribute it 3 times. You can see it can contribute 3 times. Fine. Okay. Clear. Okay, fine. So we'll do that. So after that, I will not stop. I will increment the pointer. So currently I was B. So 3 times, let me add 3. So it will come at this pointer A. So A becomes 5. Okay. So in this right now, see the window has changed. Now 5, 4 and 3. 5, 4 and 3. This is the window. So if this is the window, it can contribute how many times? This is the 1 time. This is the 2 times, 3 times, 4 times. How could I get the 4 times? Minimum 1. What is the minimum index? Plus 1. Plus 1. So 3 plus 1, 4. So 4 times I can get. So I will again continue and get 6. So this gives 6. So again it is a 6. So what is the window? Window is nothing but 6, 4 and 3. 6, 4 and 3. 6, 4 and 3. This is another window. So this is the I can contribute. It can contribute. So it will take 6, 4 plus the again 4. Minimum one is 4. Minimum is 3. 3 plus 1 is 4. So it will becomes 4 and it will 11. So if you noticed, my case was 11 was 11 in this case. Answer was 11. In this case, answer was 11. Okay. So let's see our bigger example. This one. This big example. So that time I got 63. Can I get 63? Okay. So let's say copy. Can I get 63 in this case? So this is my case. My ABC. ABC. It will everything will initialize as -1, -1, -1. So I will start with this index position. A becomes 0. Then nothing, everything is invalid. So even though each step what actually I are doing, each step I am finding the minimum of ABC, plus 1 I am doing, right? So if it is an invalid, sorry, if it is an invalid, then minimum of ABC always gives -1 by default. If it is an invalid case, see at the first index I have done, A will be updated at -1 to 0. Now if I find the minimum of these three, so minimum of these three is nothing but -1. After that I am doing plus 1, right? So by default it is adjusted. In minimum of -1 plus 1, it is adjusting to the 0. So it will not contribute anything. So by default I don't need to check. So check whether it is a -1 or not. It is somehow it is adjusted, because at the end I am doing plus 1. So -1 plus 1 becomes 0. So that's why I am initializing as -1, not as 0, not as 1, -2 or something. I am initializing as -1. So it will be adjusted. I am doing plus 1. So it will be adjusted to the 0. Okay, so let's continue our algorithm. So it is 0. So -1 is there. So minimum is -1 and plus 1 is 0. Now A becomes to fast index. So A becomes 1. Again it becomes minimum is -1. 1 is added to 0. Then A becomes in this place. Index becomes 2. Again minimum becomes -1 and plus 1 is 0. It will not contribute. So count is still now 0. Fine. Then this comes C. C is appearing. C is upgraded by 3. Fine. So again, if I find the minimum one is -1. Again, plus 1 is 0. Fine. So now this is my B. This is my B. B becomes 4. Okay. Let me rewrite everything. Remove everything. So A is 2, B is 4, and it is C. So 2, 4, and 3. This is the window. This is the last time all three characters has appeared. Okay. So all three characters appear. This is the last time. So if I found the window 2, 4, 3 is nothing but this one. So this is the window. So I have traversed my left to right. Okay, so I have second to left to it. Now I am trying to see from this window and how many characters present to the left side, how many value substring it can create. It can create how many substring. The formula is the minimum one. So minimum one is that's why 2. So 2 itself, and before 2, two other indexes as well. So 2 plus 1, 3. So itself. So that's why minimum one is 2. Minimum was 2 means minimum index is 2. This index is 2. That means index can point another thing. If you notice, index point how many character present before me. This 2 index is 2. That means 2 character presents before me. The index is 3. Index is 9. That means 8 other indexes present before me. So minimum index 2 means different character present before me, and I have to count myself, right? So that's why 2 plus 1 or minimum index plus 1. Minimum index or any index can point how many characters or how many position is available before me. Okay, so that's why we are doing minimum 1 plus 2. So minimum 1 is 2, 2 plus 1 is 3. So I'm adding 3 here. Fine. So my it was currently point to the B that time. So B is done. After that it point to the A. Point to the A, it becomes 5. So minimum was what? 3. Minimum was 3. 3 plus 1 is 4. Okay. Now it will again point to 5. Sorry, B. B is current now 6. Minimum was what? 3. So it will again 3 plus 1, 4. So again, why, if you give the example, why 3, see here, what is 6, 5 and 3? 6, 5 and 3. This is the our window. So 6 is stays. So because I have to take a valid window, na? So that's why C is not updating. C is not updating. That time this window somehow it is creating a window, and window gets kind of fixed. See here, C will appear this time. That many time A will increment, B will increment, something will increment, but C will not increment because this is the last time C appeared, and I have to consider this C. This is the as a valid pointer, valid character, valid substring. Okay. So anyhow, so again I have to increment this. Right now it is pointing to C. It is now pointing to A. Index is 7. So again 3 is the minimum because that is my window. This is my window. This is my window. So this becomes 3 plus 1 is 4 again. Fine. Again it incremented. A becomes 8. Again it will be 3. So it becomes 3 plus 1, 4. Fine. So up to this is the right now position, and this is the cases. So okay, I forgot what is the 8, 6 and 3. Fine. Current case are 8, 6 and 3. Okay. So right now pointer will increment, come in this point, 3 becomes 4. So sorry, 3 becomes 9. So what is now window got changed. Earlier the window was still this point, earlier window was this. Now see, now I get new C and I have latest A and B. Latest A and B are these pointers. Latest A and B are this one. So window now changed. So it has changed from this window to it is shifting to the this window. So window has been changed. So what is the minimum? So right now minimum is this one. So how many characters this part of substring can create? How many extra substring it can contribute? I'll check the left side only. So earlier we were checking for the right side. Now we'll check the left side. So earlier I was checking for I taking entire thing and creating all the nodes, create the possible in the right side. Now I am checking for the all the valid substring can be created from the left side. Okay, so this is now we can how many times we can create. So 6 plus 1 is 7. So I can create 7 times. Fine. After that, what can you see will be incremented here. So A becomes what? A becomes 10. Minimum is 6. So 6 plus 1, 7 again. So again, it becomes B. B becomes 11. So 9, 10, 11. What is the minimum? 9 is the minimum. So I can create 10 times. Okay, 9 plus 1, 10. So after that, it becomes A. A becomes 12. Minimum is 9. So 9 plus 1, again 10. Fine. And after that, A becomes 13. So again, minimum is 9. So 9 plus 1, 10. So again, finish after the iteration done. So it will finish. Let's calculate how many times we got. We'll get 30 times here. Then 16 plus 3, 19 times here. 19 times here and 14 times here. So if you do it, 30 plus 20, 50 minus 1, 49, 49 plus 10, 59 plus 4, 63. 63 is there. So what is the earlier count? Earlier count also 63. So this is where we can also find the solution. So if you see the algorithm here, it is very simple algorithm. So let's say function. So function is number of substring. It is what s. In that case, what I need a count variable to store the count. Okay. So right now I'll iterate for each character. So for I equals to 0, I less than n. So I need no need n. I can directly calculate is dot length here. Length. Then I plus plus. Okay. I need a frequency as well. Like earlier, I need also storing the frequency. This frequency right now, it is not frequency. It will be a my current point at this point in. Okay, so it will I'm storing the frequency. So let's say not frequency, like last index position. So IDX. So last index position is it's a map again. It's a map of character again, character and int. Okay. After that, I will create that index. So IDX of A is -1, IDX of B, index of last index of B is also -1, last index of IDX of C, this is also -1. Okay, so all are -1 initially. So after that, every time I increment the count. So how would I increment the count? Simple, like IDX of S of I can do, and plus equals to 1. So plus not plus equals to 1 equals to I, current index equals to I. Okay, and I will do simply count plus equals to 1 plus this IDX of 1 plus minimum of all three IDX, right? So minimum of 3 index. So IDX of A, IDX of B, and IDX of C. So these three I can do, minimum of these three. So this is the trend. What is the why you can do without any error? Because see, index and initial is -1. If anything is invalid, let's say it is 5, still those are -1. That time minimum return is -1, and this is 1. 1 plus -1 gives me 0. So 0 will be added into the count. So it will not create any problem. So that's why you can simply do this kind of stuff. Okay. Fine. At the end, we can return simply return simply the count. Okay, fine. So what is the time complexity here? Time complexity here is big of n. Simply I'm creating only once. Apart from that, then everything is big of 1. Yes. So earlier it is big of 2 n. You can think of it, but right now it is big of n. It is much simple, but it is a very much intuitive approach. You have to find out this pattern. Otherwise, you can't find do this thing. Space complexity is big of 1. No extra space we're using apart from those 3 extra variables. Okay, fine then. So that's all. Hope you understand the problem. As always, if you find any mistake in this video, please let me know. And if you found any useful information on this topic, please also let me know. Thank you. Bye bye.